Okay, in this video, we're going to go over the kinematics exam, the last exam for Physics A. Before we begin, if there's anybody in the room that has not taken or finished the exam, they need to get all the materials they need and leave the room and go into the lab and finish that test first. Again, that's anybody who hasn't taken it or anybody that hasn't finished it. All the handouts are at the front cart. Chromebook should be in the lab. Everybody else should have their Chromebook in front of them with their test answers pulled up. They should be ready to take notes of what questions they get wrong so that they can prepare to reassess. The announcement on Canvas posted for today has the two sections of this test and the questions that go under each category. So be ready to write down the questions you get wrong so you know which sections you would like to reassess. Okay, starting in this first section, directions for questions 1 through 5. Identify whether the following is a time interval or time instant. Select A if time interval or B if time instant. You have to remember the definitions for the two. An interval of time refers to a passage of time, a particular amount of time, or the elapsed time between two events or two moments or 2 points in time. While an instant refers to one specific moment or one specific point in time. For number 1, it says you set your alarm to ring at 3:27 p.m. 3:27 p.m. is one specific moment, one specific point in time. So for number 1, you should have selected B for instant. Number 2, the time it takes to drive from Providence to Nibley. This is referring to an amount of time or the elapsed time it would take to make that drive. So number 2, you should have marked A for interval. Number 3, the moment a bug hits the windshield. Again, that is referring to one specific moment, so you should select B, instant. Number 4, how long it takes to run a 5K. How long, that question refers to how much time has passed by or how much time is required to do something. That is referring to an interval of time, so you should have marked A for number 4. Lastly, number 5, time spent stopping a truck from 50 kilometers per hour to 0 kilometers per hour. This is referring to an amount of time, how much time it would take to stop a truck going from however fast it was going to 0. So this is referring to an interval. So for number 5, you should have selected A. Next section, directions for questions 6 through 12, select to provide the best response for each of the following prompts. Number 6, if an object starts at the origin and does not turn around, then what is true about the final position, distance traveled, and displacement? And origin refers to a 0, some point in space that you have identified as 0. So if you're starting at a 0 point and you travel without turning around, then the path you have followed is a straight line. And if the path you have followed is a straight line, then you know the distance and the displacement are going to be the same. So that rules out A as an answer. We know that at least 2 of these are going to be the same. The question is the final position also the same? Well, if we remember that displacement is equal to our final position minus our initial position, and our initial position was 0, then our displacement is just equal to our final position. So therefore, distance, displacement, and final position are all going to be the same in a scenario like this. So number 6, the correct answer is B, all equal. Number 7, what is the displacement of a round trip journey to Texas, which is 1,000 kilometers from here? Do not include kilometers in your answer. Okay. This number over here, 1,000 kilometers, that is the displacement from here to Texas. But the question asks, what would be the displacement of a round trip journey? Round trip being the operative word. Round trip means that you start here and the end of your journey is back here again, the same place you started. So displacement being the shortest distance between final position and initial position, if your final and initial position are the same, then your displacement is 0. So number 7, you should have put 0 as your answer. Number 8, suppose you take a trip which covers 240.0 kilometers in 2.5 hours. What was your average speed? Speed, by definition, is distance divided by time. So I'm going to divide my distance, 240.0 kilometers, divided by 2.5 hours. And in the end, I get 96 as my answer. So for 8a, what is the whole number value? You should have put 96. For 8b, how many decimal places are you allowed? Each number in the problem has one decimal place. So for 8b, I can have one decimal place in my answer. And for 8c, what are the units for the final answer? Because I divided kilometers by hours, the units are going to be kilometers per hour. So again, 8a is 96, 8b is 1, 8c is kilometers per hour. And if you spelled that out, or if you wrote symbols like km/h or km/hr, any of those are fine, as long as I understood that you were trying to say kilometers per hour. And moving on to number 9. It says a high-speed train travels from Berlin to Zurich at an average velocity of 227.0 kilometers per hour. The trip takes 2.0 hours. How far is Zurich from Berlin? Okay. In the problem, I am given the velocity and I'm given the time. I am being asked to find how far Zurich is from Berlin. In other words, I'm being asked to find displacement. So the equation I'm going to use is displacement equals velocity multiplied by time. That comes from our velocity equation that was given on the reference page. I just have to do a little bit of algebra and move some things around. So I'll get my calculator. I will multiply 227.0 by 2. And my answer is 454. So that will be my answer for 9a, 454. 9b, how many decimal places am I allowed in my answer? Each number in the problem has one decimal place, so I'm allowed one decimal place in my answer. And 9c, what are the units for the final answer? I am measuring displacement, so I know I'm going to need a unit that is proper for displacement. So meters, centimeters, kilometers, I just need to pick which one. In the problem, kilometers was used. So my units for the answer should be kilometers. Again, if you spelled out kilometers, that's fine too. Number 10, an athlete runs exactly once around a circular track with a total length of 500 meters in 2 minutes. What is the runner's displacement for the race? Okay. I am given in the problem the total length, another way of saying that is distance, and I'm given the time. But the problem asks for displacement, not speed. I'll say that again. The problem is not asking for speed. A lot of a common mistake on this problem was a lot of you calculated the speed. That is not what the problem is asking. The problem is asking for displacement. And displacement is defined as the shortest distance between final position and initial position. If you were running around a circular track and you ran around the track exactly once, then your final and initial position are the same. And therefore, the distance between those 2 points, the shortest distance between those 2 points is 0. So your displacement for this race is 0. So that should be your answer for 10A, 0. For 10B, how many decimal places are you allowed? In the problem, both numbers have 0 decimal places. So I'll have 0 decimal places in my answer. And 10C, what are the units? Well, the units used in the problem were meters. So I will stick with meters as my unit in my answer. Again, 10 looked for displacement of a circular track. If you start and stop at the same place, your displacement is 0. Number 11. A sound wave has a speed of 340 meters per second in air. If the wave has a frequency of 185.0 hertz, what is its wavelength? Okay. This is a wave velocity equation. So I'm not going to use velocity equals displacement over time. Rather, I'm going to use velocity equals frequency times wavelength. And that was included on your reference page. In the problem, I am given the speed of the wave. And if you remember, we talked about how with a wave, waves move in straight lines unless they are forced to change their direction. And since waves move in straight lines, we can assume that speed and velocity are the same. So I'm given the speed and the velocity of this sound wave. I'm also given this wave's frequency, 185.0 hertz, and I'm being asked to find the wavelength. So using this equation, I'm going to do a little bit of algebra and get wavelength by itself. To do that, I'll divide by frequency on both sides. So I end up with wavelength equals velocity, or speed in this case, divided by frequency. So that's 340 divided by 185. My calculator says 1.837837 repeating. So for 11A, what is the whole number value for your answer? That would be 1. For 11B, how many decimal places am I allowed? Each number in the problem has 1 decimal place. So I'm going to answer 1 for 11B. And for 11C, what are the units for the final answer? The units for the final answer are going to be meters, since I am measuring wavelength. Number 12 says a runner traveled 2 kilometers east, then backtracked 3 kilometers before stopping. The displacement from the original position is blank kilometers to the blank. The directions say for 12A include the number part of your answer, do not include kilometers. For 12B, mark E for east or W for west to indicate the direction of your displacement. And because we're using E and W for our direction, we do not have to put positive or negative. Okay, it's never established in the problem whether east or west is positive or negative, but we don't need a positive negative because we are going to indicate east-west. And remember, displacement is a vector, so it does need a direction to be tied to it. So I'm going to draw a little diagram, and this will be my starting point. If I travel 2 kilometers to the east, and I'll define east to be rightward, and then I backtrack 3 kilometers, so that's 1, 2, 3. Right here is going to be my starting point, and it's clear that my end point, my final position, and it's clear that my final position is west of my original starting place. Okay? And it's also clear that I have ended, my final position is 1 kilometer west of my starting place. So for 12A, we should have put 1, and for 12B, we should have put W for west. Number 13, a musical tone played on a piano has a frequency of 410.0 hertz and a wavelength of 0.80 meters. What is the velocity of the wave? In the problem, I am given the frequency and I am given the wavelength, and I'm being asked to find the velocity. So looking at the equation sheet, I will use this equation, velocity equals frequency multiplied by wavelength. So that's 410.0 multiplied by 0.80. And my calculator says 328. So that'll be my answer for 13A. The whole number part of my answer is just 328. For 13B, how many decimal places am I allowed in my answer? This number has 1 decimal place, while this number has 2. So in my answer, I'm only going to include 1 decimal place. I always go with the lower number. Remember, you are only as accurate as the least accurate thing that was given to you. And 13C, what are the units for the answer? Since I'm measuring velocity and the units here are standard, I'm going to use the standard unit for velocity, and that's meters per second. Number 14. Which of the following is/are scalar quantities? And it says to mark all that apply. Remember, a scalar quantity is a measurement or a quantity that has only magnitude, but does not have a direction associated with it. Magnitude just means numbers. So as I'm looking at this list, I'm looking for which of these quantities are measured with only numbers, but do not have any direction. A is displacement. I know displacement includes direction, so I'm not going to include A in my answer. B, distance. Distance is measured with a number, but it does not have direction tied to it. So B is a scalar quantity, so I will include B. C, mass. Mass also does not have direction, but it does have magnitude. So I'll include C in my answer. D, velocity. Velocity is defined as displacement divided by time. So if displacement is a vector, then velocity also is a vector. Oops, sorry. Velocity also is a vector and is therefore not a scalar. So I will not include D in my answer. And lastly, volume. Volume as well, like mass and distance, has magnitude but does not have direction. So therefore it is scalar. So 14, to get full credit on this, that's 3 points total. You had to mark B, C, and E. How I graded 14 was for every correct answer you included, I gave you 1 point. For every correct answer you didn't include, I didn't give you any points for that. And for every incorrect answer you selected, I gave you a -1 point. Okay, moving on, number 15. What is the frequency of particles vibrating if wavelengths produced are 1.50 meters with an amplitude of 0.55 meters moving at 440 meters per second? Okay. I am given in the problem wavelength, amplitude, and velocity. Okay. This number here is velocity, and I know that because its units are in meters per second. Okay. I am being asked to find the frequency. So I know I'm going to be using the wave velocity equation. I will have to do a little bit of algebra to move some things around. Before I do that though, I want to point out that in the problem, I am given an amplitude. But I know that amplitude does not affect frequency, wavelength, or velocity. So that number for amplitude, 0.55 meters, is an extraneous piece of information. It is not going to be used in any equation, so I'm going to put an X through it so that I don't use it. Okay? Because I'm being asked to find frequency, I'm going to do a little bit of algebra to get frequency by itself. So I'm going to divide by wavelength on both sides. So I'm left with frequency equals velocity divided by wavelength. So that's 444.0 divided by 1.50. And my calculator says 296. So 15A, what is the whole number value for your answer? 296 will be that number. 15B, how many decimal places am I allowed? Well, this number has 2 decimal places, and this number has 1. So in my answer, I'm only going to include 1 decimal place. And 15C, what are the units for the final answer? Again, since standard units are being used, the standard unit for frequency is hertz. I suppose you could have put vibrations per second. That would also be acceptable, but I don't think anybody put that. I think most of us did correctly identify the unit as hertz. Okay, number 16. A rocket ship launches from Siberia, Russia, and orbits Earth several times, finally landing in Siberia, Russia. While the spacecraft is in flight, a photographer flies from South America directly to Siberia to take pictures of the crew when they step out of the spacecraft. Who undergoes the greater displacement? And another reminder, displacement is defined as the shortest distance between 2 points, between your final position and your initial position. Since the spacecraft launched from Siberia, Russia and landed in Siberia, Russia, it is a safe assumption to assume that its displacement is very nearly 0 if it landed in the same place that it took off from. Meanwhile, the photographer went from South America to Siberia, so he was displaced quite a bit. So the correct answer for 16 is B, photographer. The photographer's displacement is larger, even though the spacecraft orbited Earth several times. So the distance, the total path that the spacecraft followed was much greater than the photographer's. The spacecraft was not displaced very much, if at all. Now, if you're trying to get off on a technicality and saying that maybe the spacecraft took off from one edge of Siberia and landed on the clear opposite edge of Siberia, could its displacement theoretically be greater than the photographer who took off from South America and landed in Siberia? Well, I did the math, and it turns out that the greatest distance across the stretch of Siberia is still going to be smaller than the shortest distance between the edge of South America and the edge of Siberia. So the correct answer is still B, photographer. Number 17, if the frequency of a wave is doubled while the velocity remains constant, its wavelength is blank. Okay, we know that wave frequency and wavelength are inversely related. If you double one, you would have 1/2 of the other. So that is the case here. If I double frequency, my wavelength will be halved, and that is B. Number 18, if a 25 centimeter vector is drawn to represent a 50 km/h velocity, what would be the length of a vector which represents 250 km/h at this scale? This is a problem about vector lengths, not a problem where I'm asking you to solve speed or velocity or frequency or wavelength or any of that. It's simply a ratio problem, a proportionality problem. Okay? I'm going to draw some pictures. We'll say that this arrow is this vector right here. We're going to assume that it's just 25 centimeters long. I know it's not, but let's just assume for a minute it is. And this arrow, which is again 25 centimeters long, represents a vector which is 50.00 km/h in magnitude. The question asks, if I had another arrow that represented a vector that had a 250.00 magnitude, how long would that arrow be? Okay. To solve this problem, we simply have to recognize that the scale or the ratio between these two and these two must be the same. Okay. So you can set it up as an equation. I'm going to erase so I have a little more room to write. You can set it up as an equation, 25.00 over 50.00. That proportion must equal the same proportion of this unknown length over 250.00. You could then divide these two numbers and then multiply by that 250. And if you were to do that, you would get an answer of 125. Okay. I think it's also pretty apparent that the ratio here is 1/2. This top number is 1/2 the bottom number. So I would want X to be 1/2 of 250, and that is also 125. However you got there is totally fine. Bottom line, 18A, what is the whole number value for your answer? You should put 125. For 18B, how many decimal places? Each number in the problem has 2 decimal places. I'm going to have 2 in my answer. And 18C, what are the units for the final answer? Again, I am talking about the length of this vector. And the length of the vector is being measured in centimeters. So centimeter is my unit for this answer. Number 19, delta T is the symbol for, okay? In your answer, you shouldn't have put delta. Okay? We want to know what delta T actually means. We know that T means time. So are we talking about a time instant or a time interval? We know that delta T is an amount of time, so delta T is a time interval. So time interval or interval of time are both acceptable answers. You could have put elapsed time or change in time or amount of time. I think I accepted any of those. Some examples of incorrect answers would be time instant, delta T or delta time. I think I gave you half credit if you just said time, but you didn't specify if it was an instant or an interval. Number 20, explain the difference between speed and velocity. This was a problem that surprised me a little bit. I thought we had spent a lot of time in class talking about the difference between these two, but a good portion of all 4 of my classes struggled with this. Some of us were able to identify one difference. A select few were able to identify all of the differences we discussed in class, but the vast majority of us gave some interesting definitions that we never talked about in class that are definitely incorrect. So let's talk about number 20 for a minute. Remember, speed is defined as distance divided by time. So I hope in your answer you included what speed is, distance divided by time. Speed, in addition, is a scalar quantity, meaning it only has magnitude but no direction. Velocity is defined as displacement over time. Velocity, in addition, is a vector quantity. It has direction associated with its magnitude. Those are the two major differences between speed and velocity. And if you mentioned both of those differences, I gave you 4 out of 4 points. And those two big differences are speed is calculated using distance, while velocity is calculated using displacement. The other difference, speed is scalar, while velocity is a vector. Some common misanswers. Many people said that speed is velocity, but velocity just has direction, while speed does not. We have talked extensively in class about why this is not true. Remember, there is only a very certain particular circumstance where speed and velocity can be numerically equal. And that is if distance and displacement are numerically equal. And that only happens if you or this object is traveling in a straight line and not changing any direction. Okay? So it is therefore incorrect to just state speed and velocity are the same, but velocity has direction. And that sentiment was expressed many different ways. Some of you said speed is a rate for how fast you move. Velocity is the rate for how fast you move with a direction. And that's just saying the same thing. That's saying speed and velocity are the same, but velocity has direction. So if you said something like that, I think I gave you half credit for correctly identifying that velocity is a vector, but they are not the same. Only under certain circumstances can they be numerically equal. And if you have any other questions about number 20, or if you want to talk to me and maybe explain a little bit more what you meant when you wrote down what you wrote, and you think you deserve more points, feel free to email me or talk to me tomorrow. Number 21, change in position is known as blank. Well, change is represented by the symbol delta, and since we are changing our position, not changing time, then we are talking about displacement. This displacement is a measure of that change in position. So for 21, the correct answer is displacement. And 22, delta D, well, that's the symbol for displacement. So the best answer for 22 is displacement, and the majority of you got that right. A few of you gave some additional answers that I think I agree with. Some of you said change in position. Others of you said an interval of position. I think both of those are acceptable answers. But the best answer for 22 is displacement. Number 23. What is the language or mathematics physicists use to describe motion? Okay. We've talked about this in class. Motion is usually referred to by that prefix KIN, and matics, meaning the study of. So this language or this study of motion is simply kinematics. Okay. I did not penalize you for spelling it incorrectly as long as I understood you were trying to say kinematics. Okay. Almost near the end, 2 more problems. 24, what was Usain Bolt's average speed in the world record 100-meter race he ran in 9.58 seconds? Okay. We are given in the problem distance, and we are also given time. We are being asked to find speed. So I'm going to use the equation speed equals distance divided by time. The distance here being 100 and the time being 9.58. So 100.00 divided by 9.58 is equal to, my calculator says 10.43841,336. So I'm assuming this decimal goes on for a while. So 24a, what is the whole number part of my answer? That's going to be 10. 24b, how many decimal places am I allowed? Each number in the problem has 2 decimal places. So I am allowed 2 decimal places in my answer. And 24c, what are the units for the final answer? Since this is a measure of speed, and the units in the problem were meters and seconds, meters divided by seconds is simply meters per second. So m/s is acceptable, or if you spelled meters per second, that's fine too. Last problem, 25. You need to get to class 200 meters away, and you can only walk in the hallways about 1.5 meters per second. So you were not considered running in the hall. How much time will it take you to get to class? In the problem, I'm given 200 meters away. I can assume that this is distance or displacement. I think in my mind, it sounds more like a displacement, but in reality, I don't think it's going to matter. And you walk, and you can only walk in the hallways about 1.5 meters per second. So in this, If you assume it's velocity or speed, again, it really doesn't matter. As long as you have velocity paired with displacement or distance paired with speed, but again, it doesn't matter. I'm being asked though to find how much time will it take. So whether you chose the speed equation, distance over time, or you chose the velocity equation, displacement over time, either way, we're trying to find time. So we are going to we're going to divide distance by speed, or we're going to divide displacement by velocity. Again, either way, you're going to get the same answer. So displacement slash distance is 200, and the velocity slash speed is 1.5. 200 divided by 1.5 gives me 133.333 repeating. So 25A, what was the whole number value for my answer? That is 133. 25B, how many decimal places am I allowed in my answer? This number has 1, while this number has 0 decimal places, none. So in my answer, I cannot have any decimal places. So for 25B, I'm going to answer 0. And 25C, what are the units for the final answer? This is a measure of time. So I'm going to have seconds as my unit. Okay, that concludes the kinematics exam. For the remainder of the hour, you can start on reassessments. Okay? The folders are located in the back. In the green folders, you can find the kinematics reassessments. There are only 2 sections. Again, the breakdown of this test and which questions go into which section is on the announcement canvas. So you are to start those, and you can finish them tomorrow. We'll work on reassessments for the remainder of this week.